Right, well, welcome everybody to this second event of this year's Anchor Point webinar series from the Partnership for the, I forgot this name, for the Partnership for the Organization of Innovation and New Technology, or 4.0. So it's my great pleasure to introduce two very special speakers this morning. Unfortunately, as announced, Barbara Ribeiro has a last-minute conflict and cannot join us this morning or afternoon, wherever you are in the world. So let me introduce our two speakers for today's event, who will be talking to us about how artificial intelligence contribute to public value. And they have used patent analysis for doing so. So I'll look forward to the presentation. So Philip Shapira is a dear friend and also professor of innovation and management and policy at the Manchester Institute for Innovation Research at my old university, Manchester Business School, now called Alliance Manchester Business School of the University of Manchester. He's also a professor of public policy at Georgia Tech. Sergio Pelaez is a doctoral student at the public policy, at Georgia Tech, in the Georgia Tech Science, Technology and Innovation Policy Program, or STIP. And Barbara Ribeiro is an associate professor at the Schema Business School at the Université de Côte d'Azur in France. So it's my great pleasure to welcome Philip and Sergio this morning, who will be telling us how to measure social value of AI in the information contained in patents. So Philip and Sergio, the floor is yours.
Before Sergio speaks, maybe I can say a few words. I mean, first of all, thank you, Catherine, and I recognize a number of people in the group. So hello to you all. Commiserations on the Canadian World Cup, but there's always
we always get eliminated.
So just briefly, this is a project that's coming in part from some NSF-funded work on technology and emergence indicators, and also partly from our work on 4.0, where we have a project at Georgia Tech. There's a lot of attention, I think, in our community and other communities on patents. And there tends to be a focus on the private value, particularly from a company perspective. What we're doing is adding in, maybe the other side of the equation, trying to think through what public values are expressed in patents. And if we can work that one through, as Sergio will explain, subsequently we want to associate this with indicators of technology emergence and the nature of innovation ecosystems. But this first step is a big first step. But just by way of background, Barbara Ribeiro and I did do some work, which is in research policy, earlier this year around the public and private values of innovation. And we kind of experimented with ways of working out what public value is in a patent. We did that manually and manually coded 95 synthetic biology patents, which that in and of itself, was many thousands of pages of text. And I always wanted to see, can we automate this if we're going to do it at the large scale? And that's exactly what we're trying to do here. So with that, I'll turn it over to Sergio, and let you present, this next step in the work that we're doing. I should mention, after Sergio speaks, Niels Newman is with us as a private sector commentator. And thanks very much, Niels. Niels is the president of Search Technologies in Norcross, Georgia, and has worked for many years on the development of analytical tools in the management of technology, including Vantage Point software that many of us use. And he's worked a lot around pattern analysis. So I'll let Nils say any more things, but just to say that if Nils can have the first comment after Sergio talks, and then we can open it up. Thanks, Nils.
No problem.
Okay, Sergio, it's over to you.
Okay, so I'm going to start sharing my screen. Okay. So yeah, thank you so much for inviting us to present this work in progress here. As Professor Shapira has said, this is something that comes from his previous or derives from his previous research with Professor Barbara Ribeiro, which is also a co-author in this research. And we're also working in this research with Gaurav Verma, which is also here, which is a PhD student in computer science at Georgia Tech. So the title of this research is How Does Artificial Intelligence Contribute to Public Values? A Large-Scale Patent Analysis. I will begin by introducing the topic by showing the research questions that we want to address, clarifying some definitions and motivating the questions. So the first research question that we have here is, what proportion of artificial intelligence patents in the US include public value propositions? The second one is, what kinds of public values? And here we seek to create an ontology of public values based on on their ability to sort them into different topical categories. And the third one is exploring the motivations and drivers that inventors and attorneys have in expressing public values in their patents. So we ask, why do assignees express public value propositions in their patents? So these are our main research questions, which are also going to derive in specific outputs for each of them, which I'm going to explain a little bit more in the next slides. So first, just some clarifying definitions here. What are we talking about when we're talking about public values? I'm going to read the first definition, which is a broad definition, which encompasses the general idea of a public value, and then I'm going to move to a more tailored definition to the case of public values in patent. So the first definition says public values are beliefs and activities in a society that are regarded as desirable for the functioning of that society relative to a normative ideal of human society that gives meaning, direction, and legitimation to collective action. And paraphrasing Boseman, these are articulations of desirable states that help us assess human progress against those desirable states. And the more tailored definition is the second one, which comes from the research of Professors Ribeiro and Shapira, which is, in the case of patents, is statements regarding the potential social benefits of an invention beyond the value to patent holders. So some examples of public values could be ensuring that we have a human dignity, a fair society, that we develop modes of production that are respectful with the concerns of local stakeholders and the environment. And in the case of patents, we are also including here not only potential social benefits of an invention, but also potential harms, and not only the value of that invention, but the impact in a broader sense, which is to say that both inventions that create or contribute to public values themselves, but also those that acknowledge the potential threats that they pose to society, in this case through patents, are regarded as going in the right direction toward better integrating public values within these emerging technologies. So then why public values in artificial intelligence and why patents? The first point is I'm going to answer to why artificial intelligence, and in this case in general, general purpose emerging and transformative technologies like AI are opportunities to discuss the value foundations of our society. So they pose new ethical, societal, and moral challenges that let us not only discuss existing public values, but maybe recategorize public values and create new potential categories of public values. And in the specific case of AI, we have seen that applications are now everywhere and growing. So some examples in our daily lives include risk analysis, recommender systems, matching services, and these are all things that we are every day interacting with and are expected to keep growing and becoming even more pervasive. And the second reason is AI comes with great opportunities, but also some potential threats. The opportunities, some examples or promises are early disease detection, prediction of natural disasters, and reduction of car accidents are some examples. And in the threat side, we have privacy violation, algorithmic bias, increasing market power of few giant tech corporations, and threats to democracy through diffusion of fake news and some other examples. And the second point that I'm going to emphasize here is patent texts are a great source to evaluate these value expressions, because it is in patents where precisely the creators of these inventions claim their value to society. And in principle, that value just comes from the fact or the idea that the assumption that these inventions are non-abstract ideas, that they are novel, that they are non-obvious, and that they are useful, which are just the basic requirements to get a patent. But none of those necessarily translates into public values, and that's also echoing on what Professor Shapira was saying. Is most or the most explored part of this research is about the private values of patents. It is also the most common kind of claims that we find. So, for example, a patent claims how the patent supports the competitive strategy of a firm by making it more productive, by differentiating it in the market. But we don't find that commonly public values. But the third point is that even though they might not be as common as the research of Professor Shapira and Ribeiro already showed, at a smaller scale, is that public value expressions have been found in patent text, in that case in synthetic biology. So patents and artificial intelligence, for these reasons, give a great opportunity to evaluate public values. So I'm going to show in this part what this research does, and actually also how it does it, and the kind of outcomes that we are going to expect from this. I'm going to use this flow chart to show it, and I'm going to break it into pieces just to make it visually easier to see by zooming in into the different stages that we have. But before that, I'm just going to talk generally about it. Beginning from the left, we have this first stage, the purple blocks, which are about the creation of the database. The second stage, the orange blocks, are the identification of public values in that database, and the third stage, the blue blocks, are how we use a machine learning language model to classify those patents according to whether they acknowledge public values, and also some other auxiliary questions that we can derive from that. So the first, I'm going to show the first block, this one right here, the creation of the database. So we first begin by creating a data frame of artificial intelligence patents. For that, we use Innovation Q+, which is a search tool where we can implement a search strategy that was already developed in a previous paper by Liu and co-authors, one of them, Professor Shapira also, where they propose a search strategy based on CPC codes, IPC codes, and keywords, all of them from artificial intelligence, to obtain a list of patents and patent applications that belong to artificial intelligence. And what we are doing is updating this search strategy to have more recent cases. And this gives us IDs of patents, AI patents. We, however, from Innovation Q+, do not have the full text of the patent, which we needed for the task that we're going to do. So we need to go down to the next block, which is getting that text from the USPTO. So we use this bulk download that they offer, download the entire text, and then we merge both like sources of data, which are the IDs from Innovation Q+ and the text from the USPTO to have a merged database. And we have around 111,000 records, including patent and patent application with their full text from 2005 to 2021. The last step in this first stage is splitting that those texts into sentences, which is a more amenable form for the classification task that we are going to perform, and I'm going to explain in a few minutes. And these sentences, we now move to around 3 million sentences that we're going to classify. So I'm going to move to the second stage, which is identifying public values in this database. Here, the orange block is showing the processes that we use to identify these public values. So we begin by a deductive approach in which we obtain keywords from a literature review. So this is like theory driven. We draw from many different strands of literature, including public value literature, responsible innovation, AI ethics, and even broader themes, for example, such as sustainable development goals. And we come up with 492 keywords that are going to be used to extract sentences from this huge ocean of 3 million sentences that include only those keywords. And we move from 3 million to 30,000 subset of potential public value sentences, which is easier for us to train to label and to train the model. So right now, what we need to do at this point is try to extract from this subset of public value sentences those that we believe from a manual coding process are the best representatives of public values. So we do a manual labeling process. This is a process in which each of us in the research team read the sentences and code them according to whether we believe they include public values or they don't. And we do this independently, and then we get together, we meet again to discuss our differences and to compute the level of agreement that we achieve. So we have been achieving in the order of 80% of agreement in these annotations, manual annotations. And we have been training ourselves in learning to identify public values. So each time we meet together, we discuss why there were differences, as we try to outline guidelines and rules to reduce these differences in the next batch of labeling process. And we keep doing this by batches. So once we have these sentences labeled, we help ourselves by improving the potential subset of public values. And what we do in this case is that we put those annotated sentences. We did this after like 500 sentences that we have already labeled. In an embedding space, we use a vectorizer tool, which is called fast text, provided by Facebook, where we can put the sentences into an embedding space, and we can also put the sentences from the large ocean of 3 million sentences into the same embedding space. And what we do is maximize similarities between these two sets of sentences to try to recover another subset of public values that are going to be likely or sentences that are going to be more likely going to include public values. And this is like an iterative process in which we keep labeling until we get to around, we're expecting to have at least 1,000 sentences labeled as public values and many more as not public values, and we are close to that. So the third step is, once we have our training set, the training set being the sentences that we consider are public values that we trained ourselves, and those that do not include public values, we can use this machine learning language model to help us classify the entire universe of patents, of AI patents in the US. So what the model we use is the BERT model, which is a model that was created and put into the public by Google. And it was like there's a recent model, and it was a breakthrough in the natural language processing community, because it has some very good or desirable qualities. Mainly, it is able to understand a word in a sentence from its context. So it guesses words, hidden words, just from the company of words and sentences that surround the word. And so it deals, and it's able to read an entire sentence all at once instead of sequentially. So it's very good at dealing with context and ambiguity, which in our case is very common. So for example, we have a word like bias, which means something in the statistical realm, but means something different in the innovation, in the responsible innovation realm. And BERT is very good at identifying this kind of ambiguities that a word have just from the context that it has. So we are training the model using BERT, and with these we are able to classify all the patents. And you can see that I included the research questions here because this is going to answer our first research question. This is going to tell us what proportion of AI patents in the US include public value propositions, because we can map from sentences to patents, and it can tell us this proportion of patents that include public values, and also we can answer to what's the intensity of these recognition of public values. So we can see the proportion of a patent that is allocated to discussing public values. And we can also answer our auxiliary questions. So if we move to the top, we have our second question. We're using a topic model, which is a more inductive approach. We're letting the data speak by telling us how are words clustered together, the different type of words clustered in such a way that we can identify, for example, within public values, if we find healthcare issues, if we find environmental issues, if we find privacy issues, fake news, democracy issues, fairness, algorithmic bias, and all of these themes that are in public values. And the third question is the one below. We would also like to understand what are the determinants of these public values, what are the motivators or drivers. And we have some hypotheses regarding the fact that those, or the idea that those patents that have received public funding may have more public values or may acknowledge public values. We would also like to understand how public values relate with the characteristics of the patentee, so gender, nationality, and other characteristics that may also be useful to try to understand what are the drivers, and also maybe some external influences, such as regulatory changes, judicial decisions, or social concerns, for example, through social media conversation may or may not determine whether an inventor and an attorney includes public values in the patent. So these three answer to our question. And I come back here just to finish to that dotted line you see above, to say that we're creating a feedback. The topic model gives us an idea of what topics we have by this inductive approach. This can feed the initial keywords that we have. This is something that we can always expand, and we keep having this feedback between having this deductive model, which is based from the research, the literature review that we've made, is more theory-based, and the inductive approach, which is coming from the data and is telling us what topics the model is observing. And we expect, and this is something we're doing experiments about, that BERT is capable of discovering topics. So if we, for some reason, did not include a theme of public values in our initial keyword. So let's say we didn't include economic concentration by giant tech corporations. But we are training BERT not to learn specific themes within public values, but we're training BERT to learn public values in general. So maybe what we expect, and we're doing experiments on this, is that BERT is going to discover that this issue of economic concentration is a public value, and is going to label that as such. So that's our approach. That's what we are doing right now, and the outputs that we're going to have. I'm going to move a little faster on this part. I'm just showing here what the database looks like. Most of our text has around 6,000 words. Most of the records come from the most recent years, as it is common with emerging technologies like this. So 77% of the records come from the last 3 years. These are some of the top relevant words in terms of the frequency. So we see mainly the blue ones, that they are very related with artificial intelligence topics, and even the other ones are also at least computational topics in general. And we have some preliminary results. I'm just going to show what a public value sentence in AI patent look like, and some preliminary results in our classification task. And I'm going to read these. So these are sentences that are present in our patent, in our database, that we labeled manually, and when we agreed they express public values. And I'm beginning with the first one, that is more clear relation between artificial intelligence invention and a public value, to the last one, which has a less clear connection, but it's also something that we consider public values. So the first one says, social robots may be used to augment teaching and may have particular efficacy in working with autistic children, as well as in providing companionship to elderly persons who live alone. So this is something that is clearly relating an invention, such as a social robot, an artificial invention, with societal issues such as autism and elderly and loneliness. The second one has this a relationship between the invention, although we are not sure where the AI part is here, but we also consider this to be public value, also mainly because these are all sentences that are in a patent text. So we consider this to be relationships between inventions and public values. So the second one says, better classification of the cellular composition and attendant phenotype of individual cells in the tissue microenvironment in healthy and disease states should advance basic translational and clinical research, and ultimately improve human health. In fact, we have here also the AI part, which is mainly from the better classification of the task that they are doing here and how that impacts human health and basic research. The third one says the optimum use of this massive amount of complex data can be transformed to tremendous economic and social values. So this one is a little bit more general, only relating data with economic and social values. And the last one says the natural ecology of many aquatic environments around the world is under threat due to human activity, climate change, and other sources. So this last one is not necessarily a connection between the invention and the public value, but is only a recognition that is in a patent about public values, and we also classify this as public values. This is my last slide. Just I'm gonna show these preliminary results. I would say just focus on the red red number. The table 2. So we have some sentences that we have already labeled around 2,000. So like 25% of them are public values. The other one, the rest are not public values. We cannot train with high reliability BERT yet, because BERT is data hungry. So we need at least 1,000 sentences classified as public values, and we don't have that yet. But we have worked with other classifiers to see how it is going. So table 2 shows a dummy classifier. This one does not learn from the features of the data. So this one is only guessing to the category with higher frequency. And this is, I mean, this is not learning. This is not a machine learning based algorithm. So this is only having, and this has an accuracy rate. So those sentences that have the right category, 0 or 1, what proportion are being labeled in the right category? And we see that 67% of them are labeled as such. But when we move to machine learning based algorithms, such as support vector machine or logistic classifiers, we see that this jumps to 86% and 87%. So we're moving in the right direction of actually classifying ourselves and be able to translate this into the machine to classify, to better classify the sentences that we have. And we expect this to improve when we use BERT. And that's it. I'm just gonna say that right now we don't have an answer to this question. So the further research is answering this question, but we soon are going to have an answer to at least the first one, and then we can move to the other ones. Thank you.
Thank you, Sergio. Philip, do you want to direct traffic for questions, or do you have questions prepared?
I'll let you direct traffic, but maybe I might first ask Niels Newman from Search Technology, who has not seen this before. So this is all new.
This is a fun new. It's a great change of gears for me, because I've spent the last 9 months working on a project for somebody else where we're looking at the social harm of AI. So shift to mental gears. Fascinating presentation. Very interesting stuff. I've got some just general comments, but I also have some more detailed questions. The patent geek in me is kind of fascinated with this. I'll start off with the detailed question, and I'll move on to some of the greater. And that's, well, I guess the bottom line is, what is the, where and why are people putting these kinds of terminology, the public good terminology, in a patent application, or making it even into a grant? And it might be helpful or useful to, do you have any way of knowing right now where in the body of the text are you finding these terms?
Yes. So these are mostly in the background
Okay.
part, and in the summary too, like summary and background.
Okay, because I did pull up a quick one. I was typing as fast as I could as you were putting up some of those examples. and seeing that yeah, they were the four examples you had were showing up. A lot of them were showing up in the background. The reason I ask is it would be a very interesting finding if you found any of these things in the claims, particularly, and there you'll see a difference in the claims of the apps versus the claims of the grants. I find it incredibly challenging for a patent applicant to get something like these terminology into a granted claim, but to have it in an application claim would probably be a more interesting indicator of motivation and general direction in some of this research.
There is some, there have been some studies of that, at least one study that we know of, and it suggests that it's the lawyers who typically write the claims and they make it very precise and technical, but they leave the inventors to write that background text.
Oh yeah,
And so in a way, it is in that background text that the inventor is expressing their ambitions for this, and I think they have to they want to show this because it needs to demonstrate some public utility, I think as part of building the case for the patent. But there's a reason why it's in the background, not in the claims, because the lawyers.
Well, the lawyers will let in the inventors' claims and the applications, and then throw them. They'll get chucked in the grant. So you'll see the fingerprint of the applicant, the actual inventors in the original application, and by the time the legal process is complete, the lawyers on both sides, the examiner and the lawyers would have thrown out all the ones that the inventors thought was of value. But yeah, it probably will be in the background more frequently. Where's my the harm? Okay, we covered that a little bit. I did have on one of your slides, you were showing, since you're doing topic modeling, you're using unigrams, and you had the list of terminology found. Have you thought about running just a big grand TF-IDF on the front end? Because you had embodiment show up on your list, which is a big red flag, because that's in every patent. It's a standard term of art that will be everywhere. And so there's some of your terminology you had in that list or stuff that you can probably get a more refined view of things if you just do running a full-scale TF-IDF on all of patents can be problematic because the terms that you want to get rid of will kind of vary by the essentially at the subclass level. If you want to go class level would be the simplest way to do that. But you can see terminology at a class level and say, this is going to be in every single patent and get that out of the way. And that should make your models downstream work much better than having this background noise, which is in everything. And you don't know this in everything because you're not looking at the entire world of patents. Did you play around with any of that, or is that just that's a bit too much work?
Not yet, but you're totally right. So that, yes, this table that we have here is just like to showing the like how good the search strategy worked, to see if it actually looks something similar to artificial intelligence, and which is different to say it looks like public values, because we're gonna have like two set of tables, one of them for artificial intelligence words, and then for the subset of those that include public values, like public value terms. But you're right, this one it has a lot of noise, and something we can improve, like to improve these descriptive statistics of how the terms relate with artificial intelligence. And yeah.
And just go ahead.
Yeah, no, just was going to say, like, this could be a little confusing, because embodiment, by the way, is also an ambiguous word, because it's always used in patents, but it is also used in artificial intelligence. So it's difficult, but yeah.
Well, you then have to throw in the bigram, because it will always be numbered: first embodiment, second embodiment, third embodiment, etc.
Okay.
And so just one of the things that we've played with over the years is kind of touching these systems with a little bit of known bigrams, just to remove some noise. And so in the case of embodiment, anything with first, second, third, fourth, nth embodiment is basically descriptive of a patent and not particularly useful for analysis. But when you're working with unigrams, you're kind of it can get a little tricky, because you're right, it is something that will be in the patent because it needs to be, as opposed to just being the patent because it's one of the most common words that patent attorneys use. I'm a little curious to see if you had a chance to even peek a little bit in terms of where are these patents coming from? Are these academic? Are these government? Are these corporate? Who is kind of pushing the expressing this as a means to an end in the patenting? So have you had a chance to look to see where these patents come from?
Not yet, but that's something we have in the pipeline. So that's like the third research question, like what are the drivers, motivations, like try to identify some interesting associations. This type of information is something we're going to include.
And not to throw a wrench into works in terms of your process, but if you crosswalk the patent numbers into PatStat, PatStat has a reasonably good tagging of academic. Basically, they categorize the assignee by type, and they do a reasonably good job. This is stuff that's being done out of, I believe, out of KU Leuven, that will go through and tell you whether or not it's academic, government, or corporate, which is a quick way for you guys to sit down and say, is this coming primarily out of academic, government, and corporate? And then the funding one is going to be a huge one, problematic one to figure out, unless it's explicitly, some of the government, U.S. government stuff will explicitly state this, but less, well, if it's not done for the U.S. Air Force or Army, et cetera, it's not going to be, if it's a byproduct of a project, that's not going to be so clearly noted. My last question, because I don't want to use up all the time here, but it would be interesting to see, particularly with the work on the UN sustainability goals and the stuff that's going on with ESG and others, particularly out of Europe, which has got a far more aggressive policy of identifying issues essentially across all data sources, including patents. Is the differences between the US patenting system and the European, or particularly the EPO, going to be a major barrier to carrying forth this kind of analysis on EP data? And particularly, there's no business method patents, which takes out a lot of your software. And there's also the fundamental difference in how the US and Europe view patents, one being, what it does, and the other thing, what it is. And so if it's all in the background and it's still picked up, that would be great. But if it's anywhere else other than that, it would be problematic, I think. But I don't know if you've had a chance to even peek at the broader collection of say, EP patents to see if they have the similar type of resource of information for what you're looking for.
Yeah, we haven't yet, but this will be interesting. It just to try to understand your suggestion here. So it's trying to understand how the patent system of both countries lead like inventors and attorneys to acknowledge public values, or for us to be able to identify those public values, or both.
That's a really good question. I think if it's all in background, I think you'll be in good shape to have it show up in both US and EP. But because there's a large body of technology specifically related to AI, which is not patentable in Europe because it's classified as a business method, you won't see the data that you would expect to see if you were comparing it, say, to the US. And so that business method carve out will mean that a lot of the things that are patentable in the US are not going to appear in Europe at all. And so this may not be an apples to apples comparison with Europe if you're to do this kind of analysis. It'd be interesting to see what does pass through on Europe and would be allowed to make the grade in Europe and still be mentioning these social values. So I think comparing the two would be a lot of fun, realizing that one system is blocking a lot of the grants that would, and you can see that in the families on the U.S. patents to see how many of them actually got grants in Europe, and I suspect the number for the AI will be fairly low compared to other fields such as chemistry or biology or anywhere else, or SymBio, for instance. But anyway, I'll stop it there and open up the floor to the rest of the audience. Thanks, Phil, for the opportunity, and thank you, the three of you, for this incredibly interesting paper.
Well, thank you, Niels, for these very, very good questions. Made us think quite a lot. I was wondering, Sergio, you mentioned that there wasn't enough sentences to actually train BERT. I was just wondering whether you thought of expanding into other fields to have more sentences about what it means to be public value, and whether there is something specific to AI, because we've been sold so much promise about AI in the economy that, you know, maybe there's something specific about what is public value for AI versus generic public value from another patent. You know, that probably requires, you know, downloading a whole lot more patents, but I'm just wondering whether you kind of expanded the type of patents you're considering to measure public value.
So right now, the way we do it, I think, is our initial set of keywords that trigger the potential public value sentences are, some of them are very specific to AI, but some others are very general. So they are, for example, sustainable development goals terms, which should be useful for any kind of patent. The other option that we could explore, and we haven't yet, is when we start by labeling some sentences, and we expand that set by looking at similarities from the rest of sentences in our database. What we could do, for example, is try to expand it not from our database, but from sentences, for example, from SynBio, public value sentences from SynBio. So we try to get sentences that are similar to public values in SynBio in our database, which yeah, it could lead to maybe a new subset of sentences that we were not identifying before.
Sorry, Sergio. Go ahead.
No, I actually was going to say that you may have something to say about this from your previous.
Yeah, I mean, I was going to add, Catherine. We're not short of sentences per se. I mean, we've got 3 million odd.
Okay. Specific to what is public value.
I don't think we will be. What's the challenge is you know, actually you see there's kind of quite a lot of manual processing in this in order to train it, an iteration and going around loops. You know, we're trying to get to 1,000 sentences, and which I guess some experts have said that's about the minimum you need, and if we can get to a bit more. But, you know, there's the constraint, you know, our ability to, you know, sensibly train, and Sergio mentioned all the discussion that we have around, we're going to have a robust method. Maybe if we do it another time, there may be other ways of, you know, of speeding up that process. You know, is AI a good target? I mean, why not? I mean, because it is it's across so many patent classifications, and you know, inventors from all kinds of disciplines are putting forward AI innovations, and it's also one, I think, as Sergio said, that has been greatly discussed from its societal perspectives, and you know, we wonder whether the rise of certain kinds of discussion might influence the kind of values that get mentioned about. So yeah, I think as a starting point, AI is a good one, and of course, if it works, maybe it can be developed into other fields, or as Bill said, other patent offices around the world, as well as other you know, technologies.
But since I have the three of you in front of me, one thing that you inspired in the discussion that you had, and I refer to your first comment, Nils, about the fact that you were looking for harm. With some of my students, we're looking at what is the signal that is being advertised in websites. And I'm just wondering, with the work that you're doing, whether you could have social value put in the background, and Nils actually finding harm in the patent? Could you have a signal of public value, but deep down what the patent is bringing is harm to society? Just wondering whether that, you know, we could have, you know, a greenwashing versus green compliance type of measurement to try to disentangle what the signal of public value is versus what the patent really does. I'm just wondering, you know, just to hear the two of you on that possibility, whether that's feasible or not.
That's
Not this year.
I mean, that's a great question.
Months left.
Yeah.
You know, what does it say when there is no expression of public values in patents? So it's almost like deliberately not wanting to say anything about it. Although some of these patents are very technical, you know, and relate to optimization of software systems, and maybe it's hard to think of what that might mean. But then there are the patents that express values, and I don't think we've come across one that says we're going to do harm with this patent. And I think that might make it ineligible, actually, to be approved if the examiner felt it would do harm. But I think there is wording that says, you know, we want to address bias. So in a sense, bias is the harm.
Mm-hmm.
And we have a new way of avoiding bias through this particular invention. So I think, you know, you do see that as well as saying we're going to do good, we're going to solve sustainability issues, the patents do express views that they will address harms, and that's their good. You know, whether subsequently, as implemented, you know, there is harm from this, and you know, it's another kind of a question, I think, and I think we have to keep that one in mind. But yeah, just because you say it's going to do good doesn't really mean it's going to do good. But we're just, I guess, trying to understand what they say, what these patents say. That's why I think we use the word expressions. You know, it doesn't mean it's actually. What does it mean? I think that's a whole other kind of set of questions to follow up on.
All right. Well, thank you. Are there questions from the audience that we had? Because I'm just conscious that, you know, we started late and it's already 12:03 here, close to 5 o'clock in the. So Davide, yes, you have a question?
I had some question technical, but we do not have time. But I just curious to one thing which is not technical. Do you show some impact on public values, patent that contain public value sentences when it's granted and when it's not granted? Because you have some application, so probably you can follow those applications which are granted and not. So I'm interested to ask to you if you saw an impact on granted application relating to public value sentences.
We haven't explored those associations, but this is also a very interesting one. We just to mention that we have we're using simple patent families, so to override applications. So if we see our unit of analysis is an invention. So if we see an application that then becomes a patent, we only keep the patent. But it will be interesting to analyze, for example, whether patents or applications that do not become patents, although I'm not sure if we can say that, differ in their amount of public values or their likelihood to acknowledge public values. In some way, this also relates to maybe a deeper question, which is whether acknowledging public values has any influence on the probability of having a patent granted, which should not, as it is not a requirement for to get a patent. But that would be also an interesting question.
David, did you have another question, or anybody else with questions?
Several technical on the fine tuning of BERT, and but probably, you know, it's 12 and 0.5, so it's late for that. but I will write a mail to them to have some answer.
All right. Philip, Niels, any last words?
I would second the tuning of BERT as well, and that would be there's particularly as it relates to patents. There's a lot of issues with BERT. I didn't voice it earlier because what you're looking for in a patent is not normal patent language, and therefore BERT's probably, as it is probably fine. But yeah, other things in patents, it's not a training set that BERT's particularly comfortable with in terms of doing what you think it's going to do. So.
We do have another member of our team here, Gaurav Verma. I don't know if Gaurav, if you wanted to offer an observation on BERT and its reliability.
Thanks, Phil, for asking me the question. I guess there are challenges with BERT being fine-tuned on a domain that it was not pre-trained on. So as pointed out, BERT was sort of pre-trained on Wikipedia and news corpus, and it's being fine-tuned on patent corpus. So essentially there's a difference there. But when we say BERT, I think we mean these family of BERT models. And within that family, there are variants like SciBERT, which was trained on scientific corpus. And that includes technical patents as well as scientific publications. So if BERT presents us challenges, we could move to SciBERT, and that's going to be like a small delta to overcome.
Thank you, Catherine. Thanks, Gaurav and Sergio. At least I got the chance to bring you in. You're a crucial member of our team. And I'll just turn it back to you,
Thanks,
Catherine. Thanks for this seminar.
Thank you for a very insightful seminar. I mean, this is the type of stuff we're working with Davide and Pietro and Michael, who are listening in and drinking your speech. So I look forward to our next meeting. Hopefully, it's going to be in Atlanta in May. But thank you very much, all. And then we look forward to our next meeting and to our next webinar coming up, I think, in about a week or two. So stay tuned, and thank you very much, and have a good evening or good afternoon, everyone. And Philip, we're having Manchester weather here. It's terrible.
Thank you. Okay.
Thank you all very much.
Thank you.
Bye-bye.
Nice to see you all.
Thank you. Bye-bye.
Bye. Sergio, that was great.